So when you first look at this problem and it's asking for all trig functions, you see, okay, I'm looking at cotan. And if you know that cotan, if you look at this, cotan is adjacent over opposite. We know that the 5 is the adjacent side of our triangle, and 7 is our opposite side. So then when we do this, if we know that cotan is adjacent over opposite, we create our right triangle. We circle this angle down here as theta. Therefore, we know that the opposite side, which 7 goes on the opposite side, is right here. So I put 7 on the opposite side. Then I know that 5 goes on the adjacent side. So we last need to find the hypotenuse. We're going to do Pythagorean theorem. So then when we do Pythagorean theorem, we get that the hypotenuse is square root of 74. So I'll label that over here. Hypotenuse must be the square root of 74. So now that we have our triangle set up, we use that and we use SOHCAHTOA and we look at the reciprocals to find all of our trigonometric functions. Okay, so for sine, if sine is opposite over hypotenuse, we know that we have 7 over square root of 74 because the opposite is 7, hypotenuse 74. Cosine, adjacent over hypotenuse. So if we know this is adjacent over hypotenuse, we know that we have 5 over square root of 74. And for tan OA, it's opposite over adjacent, so it's 7 over 5. After you find sine, cosine, and tan, flip for their reciprocals. So we know that cosecant has to be square root of 74 over 7 because we flipped sine. We know that secant is going to be the flip of cos, so it's square root of 74 over 5. And then cotan's the reciprocal of tan, so we know it's 5/7. So then, last step, I simplify everything. For sine and cosine, I had to rationalize denominators by multiplying by square root of 74 over square root of 74 for both of them. And then when you simplify, you get for sine 7 root 74 over 74. For cosine, 5 root 74 over 74. But notice all the rest of the ratios are simplified. So now we have all 6 of the trig functions for that triangle. So for number 2, if we know sine of theta is 3 over 8, we can create our triangle. We're going to label theta here. And we know that sine is opposite of hypotenuse, so the opposite of theta is 3. Hypotenuse is 8. And then we need to do Pythagorean theorem to find the adjacent side. So once we do Pythagorean theorem, we get the adjacent is square root of 55. We can't simplify, so we leave it as square root of 55. Once we have the triangle set up, it should be pretty easy. So for the first one, for sine, we know it's opposite over hypotenuse. So we're going to do opposite, which is 3 over hypotenuse 8. Then next up for cos, it's adjacent over hypotenuse. So we have square root of 55 over 8. We know that tan is OA, so it's opposite, 3 over adjacent, square root 55. Then, for all of the reciprocals, we're going to flip. So cotan, I'm going to flip tan, so I have square root 55 over 3. For secant, I flip cos, so I have 8 over square root 55. And for cosecant, I flip sine, so I have 8/3. Now I need to simplify. So the only two that you have to simplify once you set all these up are secant. You need to rationalize, and you should get 8 root 55 over 55. And then tan. When we simplify, we get 3 root 55 over 55. Okay, so for the next few, 3, 5, and 7, you have to use a calculator because you can't find the exact values without using a calculator. So for number 3, you simply just put in your calculator. Remember, cos of this value, it's a specific number. We're getting the ratio at this angle. So as long as the mode's in degrees, you get at 0.785. Okay? Now, 7, similarly, is a little bit easier. You hit the sine button and you enter 2.3. But you need to make sure the mode is in radians, right? So at this angle, the sine, the ratio is 0.746. Mode needs to be in radians. Number 5 is the one that's a little harder. I put a star there. You don't have the cosecant button in your calculator. We know that cosecant and sines are reciprocals of each other. So instead of doing cosecant of 79.45, you have to do 1 over sine of 79.45 because sine is a reciprocal. And that value is 1.017. Okay, so for 4, 6, and 8, when you're working with 30, 45, 60 degrees and angles, you're going to need to see exact values, and we're not putting them in our calculator. So the easiest one is number 6. So sine of 45 degrees, what's the ratio at that angle? So if we use that hand trick, 1, 2, 3, 4, 5, remember that the center finger is the 45 degree finger. So if I put that finger down, right, sine is on the right hand side. I have 2 fingers, so we would say square root of 2 all over, our palm is always 2. So that's our answer. That's the ratio. Sine 45 degrees is square root 2 over 2. Now, for cotan 30 degrees, I don't know what that is, but I do know that tan at 30 degrees is equal to the square root of 3 over 3. Therefore, since they're reciprocals of each other, I know cotan of 30, I'm just going to flip square root of 3 over 3. So it has to be 3 over square root of 3. I simplify, I rationalize. I end up with 3 root 3 over 3. The 3's in front cancel, so I get square root of 3. So cotan 30 degrees is square root of 3. Similarly, I starred number 8, secant. We're going to have to work with reciprocals, and then someone might see pi over 3 and it says, wait, we need exact value. So if it confuses you, just convert pi over 3 to degrees, right? So we have 180 degrees divided by 3, which becomes 60 degrees. So think of this as the secant of 60 degrees, right? Okay, so I don't know what secant is necessarily, but I do know that cos, reciprocal, cos at 60 degrees. So I know that cos at 60 degrees, if I put the 60 degree finger down, cos is on the left, so it's going to be square root of 1 all over 2, or 1/2. That's the cos at 60. So therefore, secant of 60, we're just going to flip a half, and we get 2 over 1, which is 2. Okay, so for number 9, 10, 12, and 13, sorry, we skipped 11, and 14, we're given ratios and we want to work backwards and find the angles. Okay, so this is a little bit harder than the part before, but it's not too bad. Okay, so for this next section, what it's really asking for is it's asking for theta. It's asking for the angle. They give us the ratio, we want the angle. Okay, so what we have to do is we ask ourselves, for example, cos. Where is the ratio a half? So I use my finger trick to kind of think about it. So we know that the angle where cos has a ratio of a half is 60 degrees. So that's in degrees, which is equal to pi over 3, which is radians. We can convert it, right, to radians. And if I use the hand trick, right, 1, 2, 3, 4, 5, we can confirm that, okay, at 60 degrees, if I put that finger down, cos is on the left, right? So we have square root of 1 over 2. Okay, yeah, so the finger or the degrees, the angle is 60 degrees. That is where the cos is going to be 1/2. For tan, I'm asking myself, at what angle is tan going to be 1? And I know, I just kind of have these memorized, or we can derive them, but I know at 45 degrees, tan is 1. So I know the angle is 45 degrees. That's in degrees, which is equal to pi over 4 in radians. Remember, you can always do a conversion if you forget. And if you do that and simplify, you end up with pi over 4. Okay, so number 9 gets a little bit harder. So when it says cotan of theta equals root 3 over 3, what is the angle? And we want an exact value. 30, 45, 60, I don't know, right? So what we do know is that we're referring to the same triangle. So think of this as something that's easier to work with. It's easier to work with sine, cosine, and tan. So since the reciprocal of cotan is tan, and we're referring to the same triangle. That's what we're working with. If we simply just flip our fraction, so we'd be rated as 3 over root 3, because now we're talking about tan, the reciprocal. Let's work with tan and see what that theta, what that angle is, and that's going to be our answer. So now let's simplify 3 over root 3 for tan. Let's work with tan. So when we rationalize and simplify, we get root 3. So now we're asking ourselves, okay, what is theta? Our ultimate goal is to find theta, because this whole thing with theta is talking about the same triangle. What's that angle, right? So at what angle is tan square root 3? Is it 30 degrees or is it 60 degrees? At 30, it's root 3 over 3. So it's 60 degrees. So theta is 60 degrees, which is also pi over 3 in radians. Okay, so same thing for the next one. We're trying to find theta, but we can't think about like secant. It's a little harder to think about. So let's work with its reciprocal. So I know that secant goes with cos. And if I flip square root 2 over 1, I get 1 over square root 2. So I'm working with this right now. I'm trying to find theta. So if I rationalize, I'm going to end up with square root of 2 over 2. Okay, this is something I can figure out. At what angle is cos square root of 2 over 2? And we know that that's at 45 degrees, which is equal to pi over 4 in radians. And a reminder with the hand trick, 45-degree finger goes down, cos is on the left. We have 2 fingertips, so it's square root of 2 all over. Your palm is always 2. So we know the answer, theta is 45 degrees. Okay, so number 12, we're also trying to find theta, right? We want to know this angle. We're working with same triangle, but I don't know cosecant right now. So I'm going to work with something I do know. I know sine. So if I'm going to work with sine, I need to flip the fraction. So I'm going to say sine theta is 3 over 2 root 3. I'm going to simplify, rationalize. So we would have 3 root 3 over 2 times 3, right? Root 3 times root 3 becomes 3. The 3's cancel, so we get root 3 over 2. Okay, this I do know. I can figure out the angle. So it's saying at what angle is sine root 3 over 2? I use the hand trick to think about it. So I know that sine is on the right, and if I want root 3, I need to have 3 fingertips on the right-hand side. That would mean that the 60-degree finger would go down. So at 60 degrees, sine is root 3 all over 2. So I know that theta is 60 degrees, and in radians it's pi over 3.